Okay, so in part 2 of chapter 15, section 1 of our notes, we are going to talk about our percent of solutions. There are two ways to do this. As you can see right here, those are the two equations that you're going to need. It's a percent by mass and the percent by volume. When we're using percent by mass, this is the mass of solution is equal to the sum of the masses of the solute and solvent. So one thing that you have to remember when we talk about the mass of the solution is equal to, it doesn't want to write, the solvent, which is what's it dissolving in, plus the solute, what is being dissolved. And so that's how we get that mass right here. The other one we have is percent by volume. Percent by volume is something that you're very familiar with and you don't even know it. When you go to the store and you buy rubbing alcohol, you'll see that it says 70% isopropyl alcohol. That's telling you the percent by volume of isopropyl alcohol within that solution. When you buy hydrogen peroxide, you're dealing with like a 1% or a 3% hydrogen peroxide per volume. And so it's kind of telling you what you have in there. So let's work through a couple of these problems. So in question number 1, it is asking you what is the percent by mass. So we use this first equation here of sodium hydrogen carbonate, aka baking soda, which dissolves 20 grams in 600 milliliters of water. So the first thing that we need to know is kind of look at what we have. So we have our 20 grams of NaHCO3 or sodium hydrogen carbonate, which is our solute. Then we have 600 milliliters of H2O. This is our solvent. Okay, but in this problem, we need to have grams. So we should remember this one equation, put this somewhere where you remember forever. Amen. 1 milliliter of distilled water is equal to 1 gram of H2O. So they're equal to each other. So this would also be equal to 600 grams of H2O. So we have to find our mass of our solution before we can go any further. So we want to take our 600 grams of H2O, add it to our 20 grams of sodium hydrogen carbonate, and we get 620 grams of solution. For there, we just have to put it into the equation. Now it's asking for a mass of sodium hydrogen carbonate, and so we need to use our 20 grams of NaHCO3, which was given to us in the problem, over our 620 grams of solution. A total volume of solution is definitely needed to do this. And when you solve for this, you should get like 3.23% NaHCO3. Note, this is a very small portion of solution, but if we would put vinegar in there, we would still get a reaction. So let's go through and do another problem just like this. In this case, we're going to be using bleach, one of those cleaners that becomes super necessary during this time. And so we have 1,500 grams of bleach, and it's telling us sodium hypochlorite is in a 3.62%, and then we need to know how many grams of that we have and how many grams of our solvent. In this case, our solvent is water, so that's nice to know for this too. So here's what we know. This is our solution, and this is our percent of our solute. So an easy way to do that is, since we already know that, we can set up the mass of our solute. So this would be X grams of NaOCl over our 1,500 grams of solution times 100, and it tells us we have a 3.62% solution. And then we just solve for X. And in this case, when we solve for X, X is going to be equal to 54.3 grams of our bleach, or sodium hypochlorite, OCl. And then we need to solve for water. Well, that becomes a lot easier because we know the mass of the solution is equal to the solvent plus the solute. So all we have to do is take our 1,500 grams of solution, subtract it from the 54.3 grams of our solute, and you would get a total of 1,445.7 grams of solvent. Now, me being a chemistry teacher, I know the solvent is going to be water because that is a universal solvent, but it doesn't necessarily have to be water. So now what about those other equations we said? So we just did percent by mass. Well, now let's do percent by volume. So percent by volume, again, is what we're familiar with. We probably don't even know it, but that's what we buy when we buy solutions at the store, such as acetic acid or ethanol in there. So what is the percent by? I apologize, spelling error here. Should be volume of ethanol in a solution that contains 35 milliliters of ethanol dissolved in 115 milliliters of water. And so when we're looking at that, we have to remember, okay, what do we have for everything? So we have our solute. In this case, our solute is going to be our 35 milliliters of ethanol. And then our solvent is equal to 115 milliliters of water. Now, milliliters is not the SI value. However, for this, milliliters is totally fine because everything is in milliliters. So, and we would measure most of our measurements in milliliters. So just leave it in milliliters, even though it's not the SI unit. So now we can figure out the total mass or total volume of solution. We simply add these two together and you get 150 milliliters of solution. So percent by volume, we need to have our volume of solute, so that would be our 35 milliliters of ethanol on top, over the volume of the solution, so that is 150 milliliters of solution. Remember, that's your solute and your solvent, times 100, and in this case, we get an answer of 23.3% ethanol in solution. We have to remember that this is only a 23.3% ethanol solution, which means the rest of it becomes a water-based or solvent-based in there. The solvent will always have more of within our solutions than we will solutes, by the way. So let's do another one. So if we have 100 milliliters of a 30% aqueous solution of ethanol, what is the volume of ethanol and the volume of after within that solution? So we know a couple things. One of the things we know is solution is equal to 100 milliliters, and our percent volume is equal to 30%. And so we need to know our ethanol, which is our solute. That is our unknown for this situation. So we would simply put it up as X is divided by 100 times 100 is equal to 30%. It's easy to find the solute for this. And so this would be 30 milliliters of ethanol we would need to make this. Now, what about if we need to know not just the solute, but the solvent? And so we would just take 100 minus 30, and it gives us 70 milliliters of H2O. Remember, this becomes the solute, what's being dissolved, and this is the solvent, what it's dissolving in. This is really important. So when you're making like an ethanol-based solution, when you go to the pumps, you see it's 10% ethanol. They want to keep it at that 10%. So then they have to figure out how much total solution they want to make, and then how much ethanol and how much, well, in the case of ethanol-based gasoline that you would put into that mixture too, so that you can dilute it down. Okay, thank you.